Hello and welcome back to a new video here on the Logic Fuzzle channel again in my C++ tutorial series. Now I've decided to bring back the face cam for the tutorials as well, so that you can like see me and we can talk face to face. At least I'm gonna try to, because like the cam is a bit off, but that's not the point of the video. So back with face cam so that you can also see who's talking to you. Now last video we have finished implementing our INI parser. So we've added a whole new API set to our INI parser, the DOM API, document object model. Now this was quite a big chunk of work. We had a very long video where we were coding these features, raw, unedited as much as possible, just focusing on kind of like having a hands-on video. Now, this video today is going to be quite different. This video today is going to be, again, on the theoretical side, and it's going to be completely different on a different topic, because this is going to be the last video where we are writing C code. Yes, you heard right. In the next video, we're gonna explore the features of C++ and why we want to use C++, and in the video after that, so in 2 videos, we're gonna start and writing our simple C app, but as a simple CPP app. Now, this video is kind of like a clean-up video. Now, I'm totally aware that there are still many features on the C language and in programming in general that we haven't talked about. For example, we haven't talked about bitwise operations, but that's something that we can do in C++ as well. It's not really required. It's the same in C as in C++. Now, of course, the C language is way bigger. We had like file functions for dealing with strings, memory, we had functions for opening and closing files and all that stuff, but there are way more functions than that. There are like sorting functions that can sort an array. There are functions that can work with the system environment, variables, for example, mass functions, thread functions, and you name it. There are many functions that we haven't talked about, but this is not going to be a C tutorial, so we are not going to discuss every feature of the language C. We want to get to C++ fast, so the only thing that we are doing today here is we are cleaning up. We are cleaning up the mess that we haven't dealt with. So basically what we're going to talk about is advanced structs today. Now today we're going to learn 2 features that can make a struct better, or types in general a bit better. It's the enum and it's the union. Now before we're going to get started with that and going into the code base, I want to quickly create a new project, because we want to have everything of today nicely separated in its own project so that we don't mess up our INI parser or the INI explorer, because they work fine. Right? They work fine, we don't want to mess them up. So let's create a new project here. Let's select empty project from the list. Let's click next. It's called 06. Let's call it advanced C structs. I'm just going to call it advanced C structs. I don't think that we're going to use advanced structs in C++ as well. We might, but this is then probably going to be called different, because in C++ you can do way more things, and then it's going to be named after a specific topic. So I'm just going to call this 06 advanced C structs. I'm going to copy the advanced C structs name here, because I'm going to use it in a second. I'm lazy, so I'm going to hit create here, which gives us our new project. I'm again going to click on show all files to make sure that we are seeing the same that we see in the Windows Explorer. Now I'm going to go to my properties, and I'm going to change the target name. So of course I make sure that I'm on all configurations and all platforms, and I'm going to change the target name to advanced C structs. Hit apply. I'm finished. Now I want to quickly copy the output directory and intermediate directory, so I'm going to click one project up. Still on all configurations on all platforms. Steal the path that we always used. Paste it in, hit apply, do the same thing for the intermediates as well. Alright, there we go. Hit apply. Hit OK, and the project is set up correctly. Now we just need to add some code, and from now on I'm always going to call the main file main.c, or later on C++. So let's create a main.c file. Let's include the usual stuff, so std lib.h, stdio.h, maybe in this order, and then I'm going to do my main here. I don't need any arguments today. This main function does not need arguments. We don't care about arguments, because we are just writing some simple demonstration code here today. Now, let's talk about structs. So we used structs previously. We used them like that: type def struct, the struct, and then the type my struct, something like that, right? this is how we use them. Of course, we need to have something in here. If we don't have anything in here, it's going to give us an error. Now, this is how we use structs. We use structs to store some data in a blob. So I could like say x, let's do a view y, z, w, like a coordinate for coordinates, and what I then can do is I can create this my struct as an object. It's not an object, it's more like a set of memory, just a group, not a real object, because objects would have more features, but it's kind of like an object. I don't want to be too academic here, and then I can like say x, y, z equals, maybe let's say 10, 10, minus 10, and the w is 1 because it's a point, something like that. Right, if we do it like that, everything is nice, everything works together, and we are good. Alright, now these structs are very useful. However, we are missing a few things that, that are kind of like required to use. Now, what would we do? For example, this is like now a coordinate, or if we want to make this a bit simpler, let's get rid of the W component, let's get rid of it down here, and let's maybe rename this to coordinate. Then I'm going to create a coordinate S here, and the coordinate S is set to the following points. Now, a coordinate in this case is now a three-dimensional coordinate. It has an x, y, and z part, so it has 3 dimensions. However, we would also need a two-dimensional coordinate. So what would happen if I would need a two-dimensional coordinate? Well, I could rename this to coordinate 3D, and I could copy this over, paste this, and create a coordinate 2D. This would work, right? We can create a coordinate 2D, we can create a coordinate 3D, and then we can use them. We have a 3-dimensional coordinate and a 2-dimensional coordinate. Now let's imagine we are going to have a function, do work. Now this function, do work, has the following code. Let's now write them as comments because they will not work. If, let's say coordinate here, coordinate, I'm just going to write coordinate here, C, coordinate C, and what I basically want to do here is if C, or let's write this in C the code, if C has 2 dimensions, I want to say hello. Else, if C has 3 dimensions, I want to say word. So what I want to do in this do work function here is I want to decide the features of this function depending on the coordinate, if it is a 2-dimensional coordinate or a 3-dimensional coordinate. Now, what I could do is, of course, write 2 functions, one with coordinate 2D and one with the coordinate 3D. However, if we are doing that, we would need to have 2 functions. So we would have a do work 3D and a do work 2D. Now, the problem is if we have 2 functions, the do work 3D and the do work 2D, we again need to know which coordinate we are passing on, and it's only going to work for 2 or 3-dimensional coordinates. And you can see the issue is 3-dimensional coordinates and 2-dimensional coordinates need to be used explicit. So if I'm using a 2-dimensional coordinate, I must need to know that it is 2-dimensional. If I use a 3-dimensional, I must know it's 3-dimensional. However, there could be a use case where you are having a 3-dimensional world, but you allow 2-dimensional coordinates with the z or y or whatever, let's say z for now, z to 0. And depending if this is like then 0 and it is 2-dimensional, you are using a different rendering approach. So for example, if you're rendering like a game engine, 2-dimensional stuff can be rendered differently than 3-dimensional stuff. So if you would just imagine that everything is fixed and you're always looking at the origin, 3-dimensional stuff would need perspection and 2-dimensional stuff would not need perspection. So we would need to enable and disable these by providing the correct implementation depending on the coordinates. Now, granted, I could check if the z coordinate is 0 of a coordinate 3D and then assume it is 2-dimensional. However, this is not always the case. There could be 3-dimensional objects that are just sitting at the z coordinate of 0. So this is not really an option. Now, it's also not an option to use different functions, so like do work or render 3D and render 2D. This is not possible because all of the objects are stored in one array, for example. And if I store all the objects in one array, I need to have one unique type to store them. So in our case, we could not do an array which consists out of 2D and 3D coordinates. Surely there's a way around this, and you can always figure and wrap your head around to get something working like that. However, this is not what I want to do here. Now, what I want to do here is I want to basically make this coordinate a bit more smart. So what I'm going to do is I'm going to write the worst case. The worst case in our case is that we have three components. Three components, the 3 dimensions of the coordinate. Now, one thing that is now left to do is to store how many components we have or what dimension we have. Now what we could do is we can say like int dimension equals, or not, we cannot say equal, but we can say dimensions here. Let me quickly create a few functions that create this. So coordinate, make coordinate 2D. So if we are gonna create a coordinate 2D, we have x and y, and then we're gonna say coordinate c dimension is 2, cx is x, and cy is y, return c, so that we create this coordinate. Let's copy and paste this for 3 dimensions, make coordinate 3D, x, y, z. Now we have 3 dimensions, and we can have z in here. All right, now what we can do in our do work, we can now say if c dimension is 2, printf, let's use the safe one, coordinate 2D, and I want to print x equals, or let's do double point y percentage I, and then I say cx cy, and else if c dimension is a 3. Let's duplicate this line and bring it down, and I want to say x, y now, x, y, z. Just need to add z here as well. So now we have x, y, z. Now what I can do is I can easily call these. Let's maybe also capitalize them because I like this, and remove the 2D because it's not possible or not required anymore. Now I can say do work, make coordinate 2D. Let's create a 2-dimensional coordinate of 5 and 5, and let's also test this out with a 3-dimensional 5, 5, minus 5, for example. Let's add the new line that I always forget. And then our code would be fine, right? We have to do work, make coordinate 2D, 3D, and we could go on. Of course, we are starting the wrong project, as always. Oh no, yeah, I press Ctrl-C. This is something that you don't want to do. Right, I'm gonna click my project, say set a startup project, and if I start it now, it should compile without any issues, and we get started. So now we can see, all right, I have a typo in here. You can see the set coordinate is there. However, I printed 2D again. This should be 3D. Right, so what is wrong with that code? Why would this code not be sufficient? Well, first of all, it is. It is completely sufficient for what we are doing. However, there are ways to do it better. Why are there ways to do it better? Well, because we could now easily tamper around with that. So I could say coordinate c invalid, and c invalid would get a dimension of 50. And now you can already see the problem, right? Like this dimension type, this dimension here, the member on the struct, it is an int. It can be any value desired. The user can assign it to whatever they want. This is not good in this case because we only support 2 and 3-dimensional coordinates just out of the logic. We could also support 1-dimensional coordinates, but that's not something that we want to do. Our logic of our application should constrain the coordinate dimension to 2 or 3. Now, how can you do this? You need to define your own type that has a limited range of values available. And this kind of type is called a enum. A enum is a enumeration. We are enumerating several possible values. Now, how can we create an enum? I can create an enum by writing the keyword, and then I want to write the name. So what's the name? I'm just going to call this now coordinate dimension, and then inside of curly brackets I can type the names or the values that are possible. Now, it's not really working with values. So 2 and 3, if I would add this in that syntax, you can see it's not really a issue. Now, what you always do in C and C++ is going to be different. You want to always make sure that you write the name of the enum as well. So you call this coordinate dimension 2D and coordinate dimension 3D. Now what you can see is now if I write this like that, it is all looking good because now it basically sees text. Enums are enumerations of text. And this is why we always need to start with a text similar to a variable. Now we can see we have the coordinate dimension 2D and the coordinate dimension 3D. Now how can I use this? Well, I can just use it here, but I can't. Why can't I? Well, same as structs, I need to type def enum, name down here, boom, it works. This is just how C rolls. C always works like that. If you're defining an enum, it is always not possible to do. Of course, if I Control Z this for a second, I can say enum. If I say enum, coordinate dimension, the C language knows what's meant. It says, I tell it that it is an enum and it's automatically detecting this. This is all stuff that is not required on C++. C++ is doing that different. However, the C syntax is always going to work, but that's something that we talk about when we get to C++. Now, you can see that our assigns down here are still possible. However, if I would compile, we should get warnings. Well, we don't get warnings, interesting. However, we want to actually change this. Right now, instead of assigning really 2, we can now just say it's a coordinate dimension 2D. And here we can say it's a coordinate dimension 3D. So basically what you can do is you can use the names down here that we have defined up here. You can use them down here to indicate what's going on. So you can like see, yeah, the dimension is the coordinate dimension 2D and the coordinate dimension 3D. Now, if we are checking this, you can also easily check for these values. And in general, it just makes a hell of a lot more sense. Like on dimension, it's not really that required, but it makes a lot of sense. In C++, you're not going to be able to assign a number again. In C++, it's going to put constraints in here that it is really the value of the enum. Now, what you can see is if I hover over them, you can already see that the C language has actually assigned numbers to them. Basically, an enum is just an alias for a number. So it is still an integer. This is still an integer because an enum requires an identification, which is done with an integer. Now, if I hover over that, you can see that by default, the dimension 2D is 0 and the dimension 3D is 1. One thing that I like to do and stuff like that is I like to assign them to some reasonable values. Or not reasonable values, but values that make sense. In this case, I'm going to assign them to 2 and 3, which basically fixes this constant value to be 2 or 3. Why does it help us? This helps us because we can actually inspect this. I can now say coordinate with a order of, so the order of components, and I could just say C dimension, and it's getting automatically converted into an integer, or it should. And it should also output us now the dimension. I can see that we have the coordinate with an order of 2 and an order of 3, which is exactly what we want. So if we ever gonna deal with real numbers, this is gonna work as well because the values that are used for that enum are reasonable, right? Very simple. Enum, number values, names, very simple idea here. Now, one thing that I don't like here now is the idea that all of our coordinates are stored in here contextless. So I want to be a bit more precise, and I want to limit that somebody that tries to access a 2D coordinate accessing the 3D value. So what we actually can do, if we have a struct, we can nest another struct into it. Or at least on C++ we can do this. Now what I can basically do is I can write in a struct in here. And now, instead of type defing it and instead of giving it a name, I'm going to leave it unnamed, right? I'm going to paste in the data here. And this is now an unnamed struct. If I would do this like that, this should probably not work now. More interesting. Yeah, it works because the struct has no name. If the struct has no name, it has no effect. However, as you can see, we have now a struct in here. And what I want to do is I want to actually name this struct. I'm going to name this 2D underscore 3D. I mean 3D. Or I just said D3, dimension 3. Yeah, let's just call it dimension 3 because 3D is not gonna work, but D3 for dimension 3 works. Now, basically by specifying the dimension 3, we can now explicitly say in the third dimension I want to set the X, in the third dimension I want to set the Y, and in the third dimension I want to set the Z value. Now, it looks simple, X, Y, Z, just need to use it down here as well. D3X, D3Y, and D3Z. Now, this looks very good. Now we just need to do the same thing for the 2 dimensions so that it looks better as well. So we can do the same thing again. We can say struct, nest these together. We don't give the struct a name. We don't type def the struct. The struct is just used internally in that struct. And now we are using it for the second dimension in X and Y. And the second dimension would also work. D2X and D2Y. Now down here as well, let's create D here, D2X, D2Y. So second dimension, third dimension works like a charm. Now, you have one issue with that code. What is the issue with that code? The issue with that code is that we are now using 5 integers. 5 integers, but only at maximum 3 are going to be valid. So if the dimension is dimension 2D, only the last 2 integers are valid, and if the dimension is 3D, only the first 3 integers are valid. Now, as you can see, it's kind of like wasteful to waste 5 integers for that. Other thing here, if we are using 2 dimensions, all 3-dimensional coordinates are invalid. If we are using 3 dimensions, all 2-dimensional coordinates are invalid. So they are never going to be used both at the same time. So it doesn't make sense to have them as 5 separate integers. Now, can we solve that problem? Yes, we can solve it. The idea here is that we're going to overlap these. We're going to overlap them and basically tell the compiler, hey, overlap these 2 structures together so that they are the same values, but they can syntactically be accessed differently. Now, how can we overlap them? We use a so-called union. A union means it is a union of memory. Basically, what a union does, everything that is inside of it, which currently is the D3 and the D2, is aligned together. If we would have single variables, all variables or single types, like 5 integers, all of these 5 integers would be the same. Now, since we have a struct, they are kind of like treated as individual components to that. So we basically, in this case, we use 3 integers, and for the 2-dimensional ones, the third one is just ignored. Now, this gives us the performance that we need. Now, basically, by adding this union, it would be the same than if I would just write these 3 integers. The union unites everything together, overlaps them, union, and in fact, we just use 3 integers of storage. And by having the union struct construct, we basically just allow to access this in a way more meaningful value. Unions can actually be named, so I could call this one data, and if I would then want to access that, I would need to say data d2, data.d2, whatever, but I personally don't like to name the unions because in this case it's not really required that you name them or that you name it, but in some cases it might be because they want to especially at some point also I want to explicitly show people that you are using a union here so that they are aware of what they are doing. So you could call this like data union, something like that, that people would directly see what's going on and would always know that only one of these values is going to be valid. So the union unites the memory together, it's going to be overlapped. It's basically the x and y values are going to be the same of the D3 than the D2. And this is now also going to work. Let's try this out. And the code still works, 2D, order of 2, 3, 5, everything looks good. And I do want to do one thing. I want to make a breakpoint here to show this to you in the debugger as well. If I, oh, why didn't you? Oh, okay, because I'm on a release, and if I'm on a release, stuff gets optimized away. Why was I on release? I don't know, but let's go to debug so that we can go debugging in here and take a look on how this looks. You can see like the C has been recognized as a coordinate, and if we take a look at this, you can see that we have a dimension, and you can already see that the debugger already knows our enum, so you can say it's a coordinate dimension 2D. I could go in here and set this to coordinate dimension 3D, edit this stuff out, change it to 2, and you can see it's automatically adapting. And the nice thing is that it is nicely labeled in the debugger as well. Now you can see that we have these two so-called unnamed tags in here, and unnamed tags is just because we haven't given them a name. The union doesn't have a name. It's an unnamed tag because the struct basically does not have a name. If I would give this if I would give the struct a type name, then we would see that name here as well. But we don't need this. We could still do this. We could say like coordinate. Oh yeah, let's stop debugging. It's okay. So if I could say like coordinate 3D here and coordinate 2D, and if I would try this now, we should have, if we're gonna open this up, you can see that we now have a coordinate 2D and 3D. This is just a label that's gonna help you to make this look a bit better. However, you're still like using that struct and like defining the type. If you have this unnamed, it's like full private, and I personally wouldn't name them here because it should be seen from the name. And if I take a look at this now, you can see what the actual components are. You can see that they are overlapped since the x and y values of both of them are the same because they are the same memory. Only the set value, which is only shown in the D3, so in the three-dimensional struct, is at some random value because it's invalid, right? If I continue and go one step again in it, you can see that now the z value is -1, and we also have a three-dimensional coordinate, which means that this value now needs to be valid. Still, x and y are the same because they are in a union and they are overlapped together. And this is how you guys do advanced structs. It's not that hard. Just to summarize again, you can create an enum. An enum is basically a label that is getting assigned a value. Enum name here, or type name. Enum name would be here. And then you're basically going to find text labels similar to variables, and these are then going to be your constant values that you can use to assign these values. And of course, with an equal sign, you can directly set them to a value. You can use them then inside of a struct. You can use a union to unite memory together, so to overlap them. And you can nest structs and unions how you desire to build up what you need. So really simple here. Can mix and match then how you like, nest structs and structs, nest structs outside of structs, having unnamed struct, having unnamed unions, having named unions, and the sky is the limit. You can do everything you like. Everything you desire, everything works without any issues. This is how C rolls, simple as that. Can use advanced structs here. Alright, so that's it with the last C video. Thank you for watching. We're gonna see us in the next video where we're gonna talk about what we have done in C, what we could not archive in C, or what was not. You can archive everything in C. However, I'm gonna show you where C kind of like falls short, and it's really complicated to do stuff. And from all these aspects that I'm gonna show to you, we're gonna deduce why we need C++, and we're also gonna compare C and C++ there, or we try to do it, or I'm going to try to show you some features of C, and then I'm going to tell you, but in C++ we can do it like that, and it is better. Alright, so thank you for watching. See you in the next video. Make sure to leave a like and subscribe to the channel, and have a nice day. Bye.